So hello students, in this video we will discuss forest data structure. So basically we already discussed in the classroom what is meant by tree. Okay, so in the trees we have nodes, we have the edges. Okay, and in the tree basically we don't have a cycles. Okay, if we have a cycles then that tree becomes a graph. Okay, so this is very important to understand forest. uh, so let's see what is meant by forest. Forest is basically a undirected, disconnected, acyclic graph. Okay, so we know acyclic means there is no cycles. Okay, if there is no cycle, that's why it is called as a tree. Disconnected means what? Okay, so you know in one tree we have the nodes, we have the edges. Okay, and every node is connected. Okay, every node is connected with the one root. Okay, but here we have the trees, multiple trees. Okay, and this tree is basically a disconnected. Okay, we cannot say that there is a only one root for these two trees. Okay, so this kind of a disconnected trees combined together called as a forest. Okay, so forest is nothing but what? The multiple trees. Okay, and this is undirected. Okay, so most of the times whenever we draw the tree we are not focusing on the arrows. Okay, so if we are not focusing on the arrows it means it is undirected. So forest is a undirected disconnected acyclic graph. In other words, a disjoint collection of trees is known as forest. Okay, each component of the forest is a tree. Okay, so means if we are talking about the forest, so in the forest multiple trees are there, means one component means one tree. Okay, tree. So let's see, tree means what? A tree is again undirected, connected. See, here we have a connected, here we have a disconnected. Okay, so connected and a cyclic graph. Okay, in other words, the connected graph that does not contain even a single cycle is called a tree. Okay, so the difference between forest and tree is this is the disconnected component. Forest is the disconnected components, means we have a multiple trees, and if we have a multiple trees we called it as a forest. And in the tree is basically a single component which is connected. Okay, so in the tree we have one root and multiple nodes, multiple edges. Okay, so this is the basic difference between the forest and tree. Exam point of view, you will get one question like what is the difference between the forest and the tree. Okay, so you search on the internet, you will get the very good answer. What is the difference between forest and tree? Now, the second thing that we have to focus in this video is question. Which kind of question we are getting? So, in the model question paper, they ask you what is forest and transform the given forest into the binary tree and traverse using in order, pre-order and post-order sequence. Okay, so what is forest? So just now we have seen what is meant by forest, and now we'll see how we can transfer any forest to the binary tree. Okay, so in the model question paper they have given this kind of a tree. So here quickly I'm drawing the tree whatever they have given in the model question paper. Okay, so here we have D, E, F and I and J, and this is C, G, H, K. Okay, so see guys, this is called a forest. Why? Because see, this is a disconnected component. Okay, this is not a connected component. We cannot say that there is only one root here. Okay, so two different components are there. Okay, that's why we called it as a tree. Okay, tell me, is this a binary tree? This is not a binary tree. This is not a binary tree. So what they are saying, you have to transfer or you have to transform this forest into the binary tree. Okay, why this is not a binary tree? See, this B is a root for this first component. B is having three childrens. B is having three childrens. So if we are talking about binary tree, then binary tree, every node might have at most two children. Okay, so maximum two children are possible in the binary tree. But here in this first component of a tree, okay, or this is first component, we have the three childrens for this B. So definitely this is not a binary tree. So guys, now we have to convert this into the binary tree. So how we can convert this forest into the single binary tree? Okay, so guys, to convert this into the single binary tree, first of all, what you have to do, you have to attach all the siblings. Okay, means you have to add the edges to attach all the siblings. Okay, so quickly I am drawing this tree again. You just focus what I am doing here. Okay, see, again I am drawing this. You have to draw this again in the examination. Every step you have to show in the examination. Okay, so what I am doing, just see here. Okay, so what you have to do, see, you have to connect these siblings. Okay, see, I am connecting these siblings. Okay, I am connecting these siblings. Now, if you want to convert this into the single tree, so definitely you have to connect these two roots also. You have to connect these two roots also. So here I am connecting B and C with one edge. Okay, see, whatever the edge you are having here in the red color, these edges basically just now I added here. Okay, just now I added here. Now the next step is what you have to do. You have to remove all the edges except the left children edge. Okay, you have to remove all the edges except the left children edge. Okay, what I am saying, see, now this B is having three children. Okay, one children is basically middle children, one children is left and one is right. So you have to keep this edge, left edge as it is, and you have to remove all the other edges. Okay, means you have to keep all the left children edges as it is and rest of the edges you have to remove. Okay, for each and every node. Okay, so now this E is having left and right child. So you have to keep this left edge as it is and right edge you have to remove. Similarly with this C is having left and right children's. Okay, you have to keep the left edge as it is and you have to remove this right edge. Okay, this G is having only one children, that is K. So there is no left and right. So you have to keep this edge as it is. Sorry. Now what I will do, I will draw this tree once again. Okay, so see, after adding new edges, what new tree which I got, that I have to draw here. So I got B here, then C, okay, then D, then E, then F, then I got I got J, then I got G here, I got H here, and I got K here. Okay, see, this kind of a tree I got now. This kind of a tree I got now. See, this is my newly added node. This is edge. This is newly added 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 edge. Okay, so I will mark this newly added edge with red color. Okay, so this is newly added, this is newly added, this is newly added, this is newly added, this is newly added. Okay, so next stage, what I have to do, I have to shift or I have to move these nodes which are connected with the newly added edges by 45 degree. Okay, means what I have to do? I have to move little bit this new node. Okay, which node? The node which is connected with newly added edges, that we have to shift, that we have to move 45 degrees. Okay, so this is not compulsory step, but if you do this step, then your tree looks like means your tree looks like good. Okay, that's why this is very important steps. Okay, so what I am doing, I am drawing here the newly created tree. See, so now my first node is B. So see, B to C age, which just now I added. Okay, this age is not given in the question paper. This node, this age is newly added. So I will tilt this age by 45 degree and I will draw this C here. Okay, now B and D. B and D is already there. So I will draw as it is. Then D and E. D and E, this edge is newly drawn. So that we have to shift little bit, that we have to move little bit. Then E and F. This E and F is again newly added edges. So we have to shift little bit. Then E and I. E and I is as it is. As it is we have to keep it. As it is we have to keep E and I. Then I and J. I and J newly added age. Newly added age. So we have to tilt it 45 degree. Okay, so now I got this kind of a tree. So similarly here C and G. C and G, this edge is already exist. So we have to keep as it is. Then G and H. G and H is newly added edge. So newly added edge 45 degree we have to tilt. Then G and K. G and K is already there. So I will keep it as it is. Okay. So guys, see this kind of a tree you got now. Okay. And this is your binary tree. And this is your binary tree. So guys, if you are getting confused with the process, again you see this video lecture and you will get the idea how I am drawing this tree. Okay, I am taking one more example in the next video as a practice for such kind of a questions. Okay, so thank you.